welcome to the July edition of the Clinical AI Interest Group. We're going to start with a 3-minute introduction. And Dr. Tassin, we'd love to hear from you, who you are, where you're from, and how you interact with AI.
Oh, fantastic. Thank you so much, Nick. First of all, it's my first ever meeting. Only I had requested to be on this
Great.
forum, so very glad to be here.
Welcome.
Thank you. Yeah, and I could not find the raise button, hand button anywhere on this. I'm not
Oh,
very
yeah.
Anyway, so I am Dr. Hina Tassin. I'm a consultant psychiatrist at Somerset Trust, and also the vice chair for the Royal College of Psychiatrists, Rehabilitation and Social Psychiatry faculty,
Amazing.
and an honorary faculty for the Cardiff University. And I have been
Wow.
working at the intersection of mental health and AI, and into AI education for different clinicians as well. And I've recently submitted a paper, well, had a paper published in JMIR, again, where I've been requesting people to have psychiatrists on board for validating for AI governance upstream, because there have been lots and lots of concerns of the patient cohort who's been missing in training the LLMs, because our patient cohort psychiatry patients are
Yes.
there, the neurodivergent patients, or the patients who have been on our rehab wards for 8, 10 years, their data is not really there on it. I think that's what my
Of
basic
course.
research work really is on. And I recently went to UNIDIR to military defense security, because that's another area I've been working on, psychiatric, the gap really of psychiatrists there in terms of military and security and AI work.
And if you had to pick one area in psychiatry that is the furthest ahead in terms of deployment of AI in that area of clinical practice, what would it be? Because we hear lots of things, obviously, about the ability of agents to perform cognitive behavioral therapy and that kind of thing. But if you had to pick one that's the furthest ahead, which would it be?
Yeah. So yes, so all these therapies, I mean, it's really helping the psychologist side of things. And in terms of psychiatry, we still think there's a huge gap, and it's not really working as much. I think we're only benefiting more in actually the other admin side of things, where AI is helping us. So it is getting us more time to actually have contact with our patients, and we're not jotting notes down. It's helping us getting the medication timeline sorted. So we're helping with that. But in terms of actual treatment, that bit is not there. So more extraction of the previous notes is helping us in that side of things. So it's for the tribunals, it's easier for us to, get a grip on patients' notes. But if it comes to really deploying in terms of treatment of, high dependency, really complex cases of psychosis, bipolar, clinical treatment-resistant depressions, I think we're still really hoping for the AI to help us in that domain. But therapy,
Okay.
yes, I think it's good. But there are some equally, it is when it's helpful, then there are some concerns as well. Like recently, I've had patients who have been chatting with chatbots, actually assuming there's a clinician behind,
Yeah.
and not the validated, not the curated ones,
Oh,
not
I
the approved
see.
ones. So there
Yes.
are some concerns as well. So yeah.
Of course. Thank you so much. Great to hear from you. Thank you for volunteering and welcome to the group.
Thank
And
you.
we have one other volunteer, so we've got time for one more. So please do unmute and take it away.
Hi, I hope you were referring to me there.
Yes, I was. Yeah.
Yeah, okay. So I just finished third year of medical school, going into fourth year. I am currently, I don't know if people have heard of the Bite Labs Digital Health Fellowship. I'm currently
Yes.
undertaking that fellowship now. Just looking to sort of gain early experience into health tech, get my foot in the door so that by the time I'm ready to make the transition after F2, I'm well equipped, because I imagine by then the competition is going to be way higher than what it is now. And Dr. Tassin, I'm glad you said you were a psychiatrist, because for my Biolabs project, we're working on ADHD bottlenecks. So if it's okay, I might reach out to you, because we're going to do some surveys as well. Um,
Fantastic. What was
but
your name, just quickly, and
um,
where are you based?
Sorry, my name is Tritiman. I am based in Newcastle, also studying at Newcastle University as well.
Brilliant. And if it, and which way do you think your colleagues? I teach medical students down the University of Southampton, and I know what I think the answer to this question might be for them. But for you, how do you think that medical students are using AI most commonly in terms of their education?
In terms of right now with AI, it is mostly people just asking questions on ChatGPT. That's probably the most common answer. I did one of my friends actually, he built his own automation on so he just basically gives the automation his curriculum and it makes Anki cards for him. So I was
Yeah,
very impressed to hear that. So, people are trying out new things, but I'd say for the most part, it is just asking Claude or ChatGPT
yeah.
questions. I know I had a quality improvement project. I used Claude to help with my PowerPoint as well. So,
Yes.
yeah.
Uh, we yes, I do think that that's an amazing deployment of it, and we run a clinical AI special study unit, and the quality of the PowerPoints this year has absolutely swamped that of any other previous year. So, and which I think is a great way to use it. Absolute pleasure to meet you. Anki cards, for those that don't realize, they predated me, and so I've only come across them relatively recently. But am I right in thinking that they're basically electronic flashcards?
Yeah, they're electronic flashcards, but the next level to it is that they help with memory recall. So you can, with each card, you can rate if it's hard or easy, if it's hard, medium, or easy, and if it's hard, it will refresh the cards quicker so that it's the active recall element to
Yeah,
it.
brilliant.
Yeah.
Thank you so much. We don't have time for any more 3-minute introductions today. Thank you for our volunteers, but please do join next time, and we'd love to hear from you. Emma, over to you to just introduce our thematic section.
Thank you very much, Nick. So, we're joined today by one of my Turing colleagues, who's Dr. Federico Nanni. So, Fede, I actually found two titles for you. So, you maybe can start by explaining if you are a senior research data scientist or, in fact, a senior research engineer, and maybe what
The
the
difference
difference is
one,
between the
yeah.
second one. Okay, okay. Well, there's two. I'm telling you, you've got two titles in our system. So you can just maybe explain what the difference is. That would be useful. So Fede is part of our research engineering group at Turing. He leads research projects that are focused on adopting and adapting large language models to a wide range of applications. Your background, and you sort of specialize in natural language processing, information retrieval, with a focus on this application to studies in society, politics and culture. You've actually done, I know I've known you for quite a while, so I know you've done lots of different projects. So it'll be actually one of my questions for you afterwards is to kind of maybe reflect on the differences between working in these different areas, because I think that's actually a really interesting thing to reflect on. But today you're going to talk to us about a particular project called Project T0, Unlocking the Benefits of Small Language Models. So over to you, Fede.
Yeah,
Thank you
yeah,
very much.
yeah, yeah. Hi everyone. Yeah, thanks for the invite and thanks for the intro and everything. Look, so I have a presentation here, and we can go through it. It's going to be very informal and very relaxed. And every time there's something that is not clear, just let me know, and I can dig into the details. I realize that there are over 100 people in the call, so I'm not really sure how we can manage this thing.
In
Let's
the
see how it
chat,
goes.
maybe. In
Yeah,
the chat.
if someone
Yeah,
can monitor the
questions.
chat, I won't be able to check the chat as well. If someone
I
can
will
monitor,
check
and
it.
if there's
Yeah.
like a specific question that, or maybe people are completely lost, just let me know and I'll clarify things. Um, yeah, before I start, as Emma said, like I have a very interdisciplinary background. I come from the humanities originally, and I moved into computer science during my PhD, and then I basically continued focusing on natural language processing and now large language models, basically. So I moved from application into research of machine learning. So I'll be referring to some things here and there. I hope they will be clear. If things are not clear, we'll figure it out. Okay. Good. And on the title, yeah, it's an internal thing. There's a large discussion in my group on the perception of research data scientists as a title and the fact that people are expecting different things. So I tend to do more machine learning type of work, and that's closer to the research engineer title that's now taking place. So it's a slow rebranding, and as you've noticed, there are parts of the Turing that the new title hasn't arrived yet. So at the moment, yeah, it really depends on who we are interacting at the moment. But anyway, so let me share the presentation. Here it is. Wait, let me move this. Do you see it well? Is it all clear?
Yeah, that looks good.
Good. Let me try to just, whoops. New slide. All good.
Yeah.
You see it well. Good. All right, guys. So let's start from the beginning. So this is project T0. It started as a very small focus project at the Turing more than a year ago, and now it became like a larger research project focused on understanding the benefits of small language models in various applications. Okay, um, I'll mostly focus on a small part of the project that we did last year because it's a very clear small example, and then I'll say a bit more on what we are doing now. So currently, the project is led by Jason McEwen here at the Turing, and the team is composed by software engineers and data scientists from the research engineering team. I am leading the part on models and architecture, and Thomas is leading the research computing side. So everything related to HPC and doing things on clusters and stuff like that. We focus in particular on three things. One is the idea of combining retrieval, so information retrieval, and I'll say more about this in a minute, and reasoning of language models. The second part is on agentic AI and try to see how we can use agentic AI to automate process. And then the third part is what I'm mostly doing now. So it's focused on try to pre-train models or distill model or fine-tune models internally at the Turing. Okay, so if some of you are interested in this part, this is very new and it's part of the general efforts at the Turing on trying to develop sovereign capabilities in this area. If you're mostly interested in applications, then we have a few examples of application of things that we've done. Okay. Okay, so the first thing is usually people ask, like, why do you care about small language models, given that we have like large frontier models that we can actually use and everyone is like are using it and they are there and they are available like most of the time for free. They are like embedded in everything that we try to use, even when we don't want to use them, they are there anyway. So what's the point about small language model? So there are a few different reasons, and it really depends on the type of application that you have in mind. Some of the reasons are related to data privacy, like you don't want your data to leave your computer or your organization, so you want to keep the data local, and then at that point you need a small model that runs locally. You want to have control on the model, and this is very relevant if you are building an application and you want to make sure that you have a model there that stays the same, and then the results are reproducible, for example, because if you rely on an endpoint from, let's say, Anthropic, they might update the model, and then you need to re-update all your architecture around it. They are generally cheaper to serve and cheaper to fine-tune compared to larger models. Um, of course, they are faster. Okay, like for example, I don't know if you follow the discussion about the new Apple Intelligence thing, but Apple is trying to have like very small models on your device, on your phone, which will do quick tasks like typo correction kind of things, because it's there and it's very tiny, and it will be able to interact with you immediately instead of relying on an endpoint somewhere else. Okay. And then there are reasons around, if you do edge type of applications, like application where you don't have an internet connection, then they are very convenient. I don't know. So I took a flight like a few months back, and I suddenly realized that I'm so used to use now coding agents, and I rely on Claude the entire time. And then when you're on a flight, you don't have internet connection, and suddenly you're like, okay, what do I do now? So as small model runs locally on your laptop is useful in this situation. For example, when you don't have an internet connection. And in general, there's all this pitch in agentic AI on, well, instead of having only large models, you can define small specific tasks and you can delegate those to small models because they are like very self-contained and very cheap to use. Okay, that's the framework. Okay, so either specialized tasks, or data privacy, or control on the model, or no internet connection. Those are the components most of the time. Okay, so I'm saying small models, but usually small is a very vague term in the field. We tend to divide them into groups. There are like very, very small models. These are things that run on, on a phone or maybe on a small Raspberry Pi. Like they are very tiny models, and honestly, you use them for specialized tasks. They only do one thing. Okay, they might be connected to a camera, and then they try to do a classification, recognizing objects or things like that. I don't know if you were around when I was trying to do my experiment with the Roomba, the Turing, a few weeks ago. We put like a small language model in control of a vacuum cleaner to try to see whether it could control it. We were using one of these models, like a model that was operating the vacuum cleaner, operating a camera, and trying to move around, basically. It was a toy experiment. We were trying to see, well, the limits of these applications. So those are like very, very small model. The second group, the from 3B to 10B, these are units are usually the number of parameters, which more or less goes along the memory that you need. The second group are things that run on your laptop. If you have a powerful MacBook, for example, those are things that will run. Medium models are models that will run on university servers, for example. Okay, at the Turing, we have a few models that are available internally of medium size, and they run on our internal servers. Okay, so these are all things that are available there, and the size is more or less determined by the type of models that are available. The most famous small models are by Qwen, which comes from Alibaba, so it's a Chinese company, or by Gemma, so from Gemini family, from DeepMind. These are the two players in the field, and those are the ones that determine the size. So they release in certain sizes, and then you adapt around them. Is it all clear? Does it? Okay, good. If something is not clear, just like give me a feedback somehow. Okay, good. So just to make sure you have an understanding on how they are trained, some small models are trained from scratch, the same way that we will train large models. Okay, as you know, you train a model by predicting the next word, and you do the same with a small model. Okay, absolutely the same. Simply, they are smaller architectures. I put here two examples. One from the Allen AI Institute, Olmo. They train a model from scratch, and the other one comes from Hugging Face. Those are two technical reports showing how they train models from scratch. Okay, so these are small models completely trained without any trick, and these are things that a research institute should be able to reproduce. Okay, we've been able to reproduce some of these works with our internal infrastructure and relying on high performance computing. These are not very very complicated things to do. Okay, some others are trained via distillation. So it means that you are a company with a frontier model. Okay, you are Google. I think I have an example. Yes, yeah. You are a DeepMind. You have your Gemini model, which is gigantic. Okay, and from there you distill a small model that performs like we call it like as a teacher-student crime framework. So it's a small student model that tries to imitate the larger model. Okay, so for training via distillation is a great approach. This is the way that the best models out there are created. But for doing that, you need a larger model from which you distill. Okay, and the small model will never be able to outperform the large model because it's just learning how to imitate the larger models. Okay, but this is the typical way in which you produce like a very high performing small model. You have a large one and then you distill capabilities into a small one. Okay, the third way is it's called distilling but through synthetic data distillation, okay? So you have, I think I have an example and then it will clarify things. Do you remember when DeepSeek came out a year and a half ago? And then OpenAI said, oh, but they have trained on our data. Like somehow DeepSeek got data, like got reasoning processes from GPT-4, and then they distill their own model. That's exactly how data distillation works. So you have some synthetic data created from a very large, very powerful model, and then you take this data and you continue training your model to learn how to imitate the larger one, okay? In certain cases, this is fine. In other situations, that's not. And apparently, OpenAI was trying to make that point. Then there's another discussion on how OpenAI trained their own original models, but that goes in a different direction. But anyway, there are three ways of training models. So basically, either you train them from scratch, you distill them from a large model that you have, or you train them on synthetic data created by another model. Okay. NVIDIA with Nemotron is doing this quite a lot and quite well with their own models. And in the same framework is the thing that we did here at Turing last year. So we show that you can take a small model and you can teach this model how to reason. We'll discuss this in a bit, in a way that it will imitate another model. It's always this type of game, okay? Is it all clear? All good? Great. So, as I was saying, I'll focus on what we call at the Turing phase 0 of this project, which is a sprint of 6 weeks that we did 1 year ago, more or less, just to give you an idea of how the project works, okay? I'll be touching upon 3 topics in LLM and in agentic AI. So I'll describe them quickly so you have a clear idea of what they are, okay? But if you have any questions, let me know. So the first one is what we call RAG, Retrieval Augmented Generation. It's what you see when you use ChatGPT or Claude and you say, okay, check my sources or like double check this thing. You'll see that they do a search online, okay? This is RAG. They search, they use a retrieval tool. This retrieval tool finds some pages. It puts the pages into the context, and then the next tokens that they will predict, the answer that you will get, it will be informed by these pages that they retrieved, okay? It's a trick that initially people used to try to avoid hallucination. They were saying, well, if you search, then the tool will be more focused on relevant documents, okay? RAG in general is very useful for many applications. Like every time you think that the tasks that you want to do, that you basically, if you have a body of knowledge and the information is there, you need to do this, okay? Imagine that in your application, you have, I don't know, a collection of documents, and the query is, you know that the answer is there somewhere in the collection of document, then you need RAG. You don't need anything else. It's you need information retrieval, basically, okay? So this is one of the topics. The second one is it's chain of thought reasoning. I've already used the word reasoning quite a lot. And as you know, in AI, we tend to anthropomorphize everything. But what people mean when they say reasoning comes from a paper from 2022, which showed that imagine that you are in a setting and you are chatting with ChatGPT, okay? Input is your prompt and output is what ChatGPT will tell you, okay? So you ask, okay, what is the population of Italy now, okay? In the first setting, ChatGPT will just auto-complete the answer, okay? It will say the population of Italy is around 60 million people. I'm just guessing, more or less. And it does that just because it has been trained on a large corpus and will just emit the most likely type of tokens that you should follow, okay? That works in certain settings. It doesn't work in others. Reasoning is an approach that before producing the answer, it forces the model to emit a reasoning process. And you probably have seen it if you like all models now do this, and you can explore it and look what the model is doing. And basically the model pretends pretends to be thinking, is emitting like a thinking process in which it will say, oh, well, the user is asking me what is the population of Italy. Oh, that's an interesting question. I need to be very precise. Probably they want to have a general number first, blah, blah. And it does a sort of reasoning, okay? So the idea of reasoning is that it has been shown that tends to improve performance in certain tasks. Okay, in certain tasks, just by emitting more tokens, the performance of the model improves. Um, which I mean, now it's obvious, and we see it with all these agentic AI. There's like an entire economy around the number of tokens that you consume and this stuff. But like when this paper came out, it was quite surprising. Okay, so but when I say reasoning, I just mean this: you have a model that before producing an answer, it will create some reasoning tokens, and it will pretend to be thinking around what the model should be doing next. Is it clear? Now, all this
Sorry,
stuff.
Fede, can you just
Yeah.
talk about what tokens are? Because
Oh,
there's lots of
sorry.
different
So
explanations of that
you
usually.
you are right. Look, in this context, let's assume that tokens are words. Okay, so
Yeah.
the like tokens are subwords, and when people say how many tokens have you consumed, or oh, I pay X for million tokens, it means words. Like in our context,
Great.
it means words. Okay, so
Thanks.
um, a funny thing about reasoning, if you happen to use a reasoning model, you can explore the reasoning process, and you will see that while the model here in output is speaking to you, and you'll say, "Oh, hi Federico. Oh, you want to know this and this, blah blah blah." Here is reasoning in third person. Is saying, "Oh, the user wants to know this and that." So this is the model has been trained to do this, okay? But basically, it's it's a way for the model to improve performances just by producing more words before the final answer. Okay. Uh, all this is related to what people now call agentic AI. Okay. So agentic AI, in a very small example, is I'm asking the population of Italy. The model says, oh, the user wants to know the population of Italy. I should check this online. The the LLM calls Wikipedia and gets the population there, and then produces an output saying, oh, the population of Italy is 60 million people, something like that. Agentic AI is this, okay? It's a reasoning model here. It's a reasoning model that thinks about what the user wants. It has a set of tools that can use, searching, checking the temperature, writing some Python, things like that. Okay, there are some tools at disposal and says, oh, for doing this thing, I need to use this tool. It does an action, the action produces a result. The model looks at the action and say, oh, well, I need to do it again. Do you know when, I don't know if you use Claude or things like that, but when you use Claude, it tends to, from time to time, goes into a loop. And it's like, oh, I need to search this stuff. Oh, actually, the results are not good. Let me search it again. Oh, actually, the one from before were actually the good one. Let me go back there. That's agentic AI. It's a reasoning model with some tools. Okay, if you if you don't give the right tool to the model, the model will ask you to install some tools. It happens with Claude from time to time. It says, "Oh, I need a PDF parser because I need to parse this document, and there's no other way. Can you install it for me?" And then you are installing an additional tool for the LLM. Okay, so but this is agentic AI basically, and then we overcomplicate it putting well a lot of security things and a lot of fairy dust around. But basically, agentic AI is a reasoning model and some tools and a series of interactions. All good? Good. All right. So the project we did started from this paper that came out from Stanford more than a year ago. What they showed was basically that if you took a small model, um, let's go to this example. They show that if you take a small model and you basically teach this model how to do reasoning, the model will just like performs. It will just perform way better than previously, reaching the point that it could actually perform as well as a very large model. So they said, okay, reasoning is not really size dependent. And if you actually take a small model and you teach it to reason in a very specific context, then it can actually perform very well. Okay. They showed this in the context of mathematical reasoning. That if you check the literature in this topic, you will see that all the applications are either math or code related. And that's because it's very easy to check whether the answer is correct. Okay. So you imagine the input is a math problem. The output should be a number. And the model is just producing tokens over tokens and blah, 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 and saying things up until it will give you back a number. And then you check whether it's correct or not. That's the entire setting. Okay. So this paper came out and we got a request at Turing saying, okay, this request came directly from government and they were looked at this paper and say, okay, could this actually be a useful starting point for using small language models in application? So at the point, like more than a year ago, the field was very, very confused about the usefulness of small language models. Okay. So the question was, okay, this stuff seems to be useful for some very specific math problems. Can we actually try to use it for something more useful, something that will actually have an impact, where you have, for example, private information, and you know that there is a certain process that you want to do, but you don't want to use a frontier model for any specific reason. So that was the starting point of the project. Okay, so let me before we go here, let me say another thing. So they came with this information. Okay, they were like, okay, can you explore it, and can you please simulate a setting in which you have a private body of knowledge? Okay, so imagine at your organization some internal information, or if there are people here from Turing, you have Mattison, our internal body of knowledge. Okay, and you want to search over it and reason about it because you want to take a decision, for example, and you don't want to use a frontier model because you don't want to send your private data to ChatGPT. Okay. And we're like, oh, okay, that sounds cool. And they're like, okay, good. Now you have 6 weeks. Try to find an example and build a demo for us so that we see whether it works. So the idea that we came is medically related, but like the caveat here is don't take it as a medical decision-making tool. Okay, this is not a medical decision-making tool. This is just a simulation of searching into a body of knowledge and taking a decision from there. Okay, just like I just need to say this because we never actually tested the real, like it probably doesn't work well as a medical decision-making tool. Okay, good. So what we had as an idea was taking the NHS A to Z conditions, and we say, okay, well, that like looks like a very specific body of knowledge. Okay, you have around 1,000 pages. Each one is, well organized and well structured. You could imagine a setting where there is a user with a question. Okay, for example, I have a persistent cough and a high temperature. And the task is not simply information retrieval. You don't want to just search and say, okay, well, maybe you have pneumonia there. But there is so because if the task was this, then the task is information retrieval. You are just searching, okay? Uh, uh, but the point is, you also want to go into the page and say, well, depending on your symptom and depending on your setting, you need to take a decision. Either you book an appointment with your GP, or you call 999, or you just stay at home and, like, I don't know, take paracetamol. There it's not simply a retrieval, but it's also decision making together. Okay. And we thought that this was a very good example for a demo because you can combine the two things. And so we were saying, in every setting where you want to make a process automatic, and the process is a combination of searching and decision making, then maybe a small language model could help you there. Is it clear? So can you imagine in your setting, okay? You search and then there's decision making on top. Okay, good. So great, they say, okay, fine, this sounds good. Let's do it. Let's approach it. And so the problem there was that we didn't have any data. Okay, we had only these web pages from the NHS. And a very tight timeline. So what we did was generating data synthetically. So this was more than a year ago, but what we did was we took each of the web pages of the condition. So imagine pneumonia, for example. We sent it to GPT-4 and said, okay, can you create some synthetic queries for this page? So people who might have certain symptoms and by searching might end up on this page. Okay, so you are creating fake or synthetic people with certain potentially certain conditions. Okay, and then there you basically have a knob where you can make it harder or simpler the task. Like very simple tasks are you just hit perfectly all the type of symptoms that will be relevant for a condition, or you make it very hard. We were in conversation with a couple of GPs here, and they said, well, there are people that downplay their symptoms. So they come to you and in their description, they might have something, you know, very serious, but they are just like not really describing it carefully. So you have this type of knob on how to downplay the symptoms. And the other one were like, well, you also have hypochondriacs that will just escalate everything. And it seems that like the situation is really dangerous. So we basically, this is all about prompt engineering. We did a lot of rounds of prompting of ChatGPT, and then with these couple of GPs, we double check things together. And they were like, okay, this sounds credible. These type of queries are really not the type of queries that we see. So we did a few rounds and we select them. But given that we were like under time pressure, at a certain point we say, okay, this sounds like a potential body of type of queries that someone calling, for example, 111 because it doesn't really know how to handle the situation might see, okay? Like type of description of symptoms that you have together with some demographics. We had to control the demographics. In that sense, I mean like the age and other information about the person. Because if we relied on GPT, then you have the problem that they're always creating the same type of patient. Apparently, they are either they are strongly biasing towards certain type of patient, or they are overcorrecting it the other way around, and then they tell you completely unrealistic scenarios. So one of the GPs gave us the advice of like control the demographic first. You select them and say, for example, this is a woman, this certain age, maybe is a smoker and blah, blah, blah. And then you say, okay, based on this information, create some queries, okay? This part is relevant, and if you want, we can discuss it further or at another point, if you are in a setting where you want to create synthetic data. So it's very challenging to do with LLMs because of many different reasons. But it is possible knowing the caveats and knowing the issues around it and knowing how to evaluate this, okay? So if you want to know more, there are a few projects here focused on synthetic data creation and basically how to deal with these type of processes, okay? Good. So assume that we have these queries, then you imagine you now have a query saying, well, I'm a 50-year-old man, smoker, and I have a persistent cough for a month now. Now you search on the pages, you do information retrieval, okay? And then what we did was you take this synthetic query plus the documents that you are retrieving, and we pass them at the time to DeepSeek to see how DeepSeek will reason around the conditions, okay? It will say, oh, well, this person is a smoker. So that sounds like a very important signal that we should consider. And there are these possible conditions that they're being retrieved and blah, blah, blah. And DeepSeek will produce you some reasoning, okay? And then what we did was we took a way smaller model that wasn't a reasoning model at all. And we said, okay, now learn to imitate the way that DeepSeek, a frontier model, is reasoning and try to do the same, okay? So what you can achieve here is that you can push a small model to perform as similarly as possible to a very large model. That's the pitch, okay? So the frontier model is your ceiling. You cannot go beyond that. And this is fine-tuning. So you are specializing your model to do reasoning only in that domain and only with that style. So you are accepting these as trade-offs. But on the other hand, your model will become a reasoning model that is as good as a very large model to do reasoning in this specific domain. So these are the important things to consider when you use small models, okay? You are specializing them to a domain and to a particular way of approaching this domain. As soon as you move outside of the domain, like if you ask this model to do mathematical reasoning, it won't be able to do it, okay? Like that's the deal in this setting, okay? While DeepSeek might be extremely good at doing mathematical reasoning, you haven't taught the small model to do mathematical reasoning, okay? You only have taught the model how to reason about medical conditions. So that's the setting. But basically, by doing that, you can distill these properties into a small model that then you can use, and it will perform similarly to DeepSeek, but while being way smaller, okay? Any question? Is it more or less clear, the trade-off and the settings? Good. We used DeepSeek at the time because it was the only model that was offering reasoning traces. So you could see the reasoning only of DeepSeek back in April 2025, okay? Now there are a lot of models that offer that, basically. Yes. So we did this again earlier this year because we've been asked whether we could reproduce everything by using only Western models, because there are in general some tensions around relying on open models that you can't actually control completely. So we did it again using GPT-OSS, which is the open source version of OpenAI, and then we use Gemma from Gemini. The performance are very similar. So now it's possible, and if someone wants to reproduce this in their own setting, it is possible, and it's at the end of the day, it's a very cheap type of fine-tuning. We were able to do everything on site on one of these DGX Spark. They are small framework computers that we have here. Okay. But basically, this is to say, if you are in a setting that for any type of sensitive reasons, you can only use certain type of models, this is possible. Now you can use a large family of models, or if, for example, in some of our cases, we want to use everything that is completely open source, like from training of the model and training of the data, you can use Olmo from the Allen AI Institute, which is completely open source, and then you can do the same type of process, okay? Good. So the outcome of the project was a tool that to which you can ask question. It will do at the same time retrieval and reasoning, and it's a very small model, and it will be able to shortlist the type of condition that you might have to 5 potential condition, and it will suggest you a disposition. So what to do next, basically. Performance are well, I'll show you in a second, but the feedback that we got from the GPs that we consulted were very positive, in the sense that they say, look, from this short description, it's very hard to say what the patient has. You need to see the person, and you need to actually, you need to see this person in real life most of the time. But by being able to shortlist to a handful of condition is very useful in general, because that's what we also do. Like we try to capture some of the specific features or some of the specific symptoms and say, okay, well, if you tell me that for sure is this thing, like you are definitely moving in that direction, okay? They gave us an example about gout, which was very interesting, but they were saying something like, if someone is mentioning having pain in the big toe of their foot, like we know in which direction this thing is going anyway. Okay, so they gave us these type of examples. So we build a tool to do this. We show that performance of the tool. Here, so the star was one of the best models at the time. It was a reasoning model from OpenAI, and we showed that you can take a model that the blue line is a model that will run on a server of a normal university, will perform as well as the frontier model with a combination of retrieval and reasoning. But if you look at the line, you will see that most of the heavyweight is done by the retrieval part. RAG is here, and then RAG plus reasoning doesn't add much. But then we went smaller and smaller, and then the red line is a model that will run on any laptop. Okay, it runs on my MacBook here. And in this one, you see the story. The model doesn't perform very well initially with retrieval. So by retrieving information, you reduce hallucination. So that already improves. And adding reasoning on top, it brings the performance in this very specific task very similarly to a frontier model, to a model that you could get from OpenAI. Okay, so the takeaway is yes, you can achieve almost frontier performance, but in a very, very specialized task. And you need to do some fine tuning and things like that. And if you want to change the task, then you need to do fine tuning again. Okay, that's the deal. Like this is not a general purpose type of tool. Okay. And then we did a demo that if you want to see, if you happen to be at the Turing once, let me know and we can set it up for you. And you can chat with the model and see more or less how it performs. But it's a model that, given a prompt, it will do some retrieval, do some reasoning, and then give you an answer, basically. I have 2 slides on showing you quickly what we do next, and then we can have a quick chat if you have any question, okay? So, okay, well, an overview of the timeline. It was like a crazy month, but basically we initially obtained compute very quickly, thanks to a partnership that we have with Microsoft Azure. And then we spent initially 2 weeks on synthetic data generation and building a retrieval, 2 weeks on fine tuning. There was Easter in between. And then we had 1 week on reproducibility and doing the demo. And this was before coding agents were reliable as they are now, because most of this stuff we actually delegated to Claude now. But back then we actually had to build a demo and build this and making the slides and everything. So it was fun. It was really tiring, but it was a fun project. So what we are doing now, we have one project which is about crime recording, and this is an interesting collaboration because the pitch for this project was, look, every time a crime happens, we need, like, the police officers need to log it, okay? They have a 400 pages of instruction on how to log crimes. And they say, well, it's exactly what you pitch in the paper. It's about searching. And imagine it's similar to the condition and the symptoms. You have a crime, you need to search for the right crime. And then there are a lot of little rules about, because if there are multiple crimes, there is an order of in which you need to list them. Okay, so it's about retrieval and reasoning about what the rules say. So this is one of the, and they said, well, look, we know that Frontier's model can do this, and we want to see what the small model can, because we have some settings in which we don't have internet connection, or some other setting where we want to keep completely information local. So this is one type of application that we have in mind. Another one internally, I don't know if, Emma, we are automating the compute allocation process at Turing. So now if you are requesting compute, it will go to our bot, which looks at your application and double checks that you added correct information. And it's retrieval and reasoning. It's retrieving the set of guidelines that we have, checking that every detail that you put is correct. If it's not correct, it will come back to you. Otherwise, it will send an email to our program management unit to double check that you actually have budget for doing what you want to do. But it's basically a little agent that tries to do this thing. And as I said at the beginning, what we are trying to do now is setting up a team for learning how to pre-train these models internally so that we can actually pre-train them, fine-tune them, and adapt them to various applications with an internal pipeline. So we have expertise through the entire process of agentic AI type of things. I think that's more or less here. So just to wrap up, so you don't need large models for in every application. The small models are good in very specific setting when you adapt them. But if you have like a very specific narrow task, you can use a very small model for these kind of things. We are setting up a team for doing these things completely now at Turing. And these stuff are relevant in setting where you need to do decision making, your resource constraints, or there's data privacy. That's more or less it. I see that there's a question. So yeah, but
There is.
thanks in general.
Thank you so much.
Yeah.
Thanks, Fede. Thanks so much. Let's give Fede a round of applause so we remember to do that. There's been lots of great appreciation already in the chat for you, because I think that was a great explanation. You did an amazing job at explaining that, because it's so technical, the things you're doing.
Thanks.
Yeah,
I mean,
really
would have been easier in
accessible.
person, so we could have
I
actually
know.
discussed it.
Yes, actually seen and stuff. Right. Question, Rob. Rob Free, off you go.
Okay, so I've investigated small language models myself because I've been looking at self-management tools in healthcare and whether they might have a role in that. My conclusion based on that kind of empirical research, I don't think it's publishable, but internally, is that they're not performing enough to do that. And even at a fairly basic level, it's very difficult. Even with fine tuning, there's too much nuance in text. And as I mean, you showed the accuracy of 55% is not great. Actually, if you consider it in that way, clinical safety is paramount here. Do you think that because they're talking in the 10-year plan about creating a digital assistant for for people that would, I assume, be based on a small language model that runs on a mobile device? Do you think that's a tenable thing, or do you think it's
I think you are touching on upon two different things, and both of them are very hard. Like one is evaluation. Like evaluation of these things.
Evaluation is impossible because
it's impossible. Like it's so hard, and then you have so many variables at play. Like that 55% before, it was evaluation only at predicting the correct condition, which GPs that we were in touch with say, like, look, that doesn't make sense as a task, like because you can't actually. But in the presentation we needed a number because like people were saying, okay, how does it perform? And we're like, okay, well, fine. On what you said about support, so there is a lot of research around continual learning, which is you have a model that learns from feedback from the user. Okay.
Yes.
And that is, from a research angle, the way to go. Like this is what we want. Okay. You want a tool that learns from your feedback and you don't have to repeat every time whatever you want to say, and it doesn't.
But that's no use if you've got someone who comes to you, puts some symptoms in there that mean that they need to be clinically escalated, and the model says, "Oh yeah, you're fine. Just continue on your."
So one is, I think this is again on evaluation, like a model that says, "Look, you're fine," when you're not fine, shouldn't even be there. The other thing is, continual learning is a cool topic and people are very excited about it, but it's a research topic. It's like very far away from application. From time to time there are people trying to pitch it and you're like, look, we don't even know how to do it yet. So I think for both of these things I agree. Like, I mean, we've seen things progressing very fast, so it's very hard to imagine in 10 years now. But at the same time, I'm as skeptical as you are, because if someone will give me something like that now, I will say, no, look, this stuff cannot work. Like, there's no way. So I don't know. Like, from my point of view, I don't think it's close, but at the same time, who knows? Like, I don't know.
I had some success fine-tuning a model that just output whether to clinically escalate or not, based on the response. That was
like a
it.
classifier.
And
Yeah.
that actually worked okay. That I was getting kind of accuracy in the kind of 90%, 95% kind of range, which I thought was actually pretty good. But that's that's not really any use, is it? I mean,
Like
as a thing, you can't just have that and then go, you're right. Oh yeah,
yeah,
well,
and
I
then
can't produce a
there are
response.
people, that are a bit skeptical of all the AI hype that will tell you, but look, we knew how to train a classifier already. Like we don't need all this
Yeah.
complexity around it.
Yeah,
So
yeah.
it's hard. I agree with you. I'll pass it to who's next?
Yes, let's go for one more question because
Sorry.
we've only got. That's all right. Don't worry.
It'd be great to
only
catch
got
up
time
to
for one
speak
more.
to you in
please,
a bit more
be
detail, actually.
in touch.
I'll reach out. Yeah. Okay. Thank you.
Jotty.
Thank you so much. So it's a very quick question. Do you have an open source equivalent for the tool that you have developed, so that if anyone wants to try their hand out?
Okay, we do. I can send you the paper, and then there's a link to the repo and the Hugging Face and with everything. I wouldn't use it as a medical decision making. Like you can use it if you want to just see how crappy it is, but like it was a proof of concept. Okay, like please don't use it. Yeah, I wouldn't use it as a medical decision. But if
I
you
know
want to use
Jotty.
it
She
as a
doesn't work
baseline,
in that field anyway, so
okay, good,
she's
very
another
good.
engineer. So
Okay, very good. Oh,
Yeah.
okay, perfect. Yeah, if you want to use it as a baseline, yes, yeah. Just say,
Yeah.
okay, this was a starting point on this was the state of the art on this area a year and a half ago. Yeah, fair. Okay.
Yeah.
If you want to do a final one, I can stay in the
Okay,
call for a
great.
couple of minutes.
Kevin, let's go.
Yeah. I suppose well, you've kind of covered it. I mean, I had a technical question about model drift and calibration and stuff like that, right? But that's all the big question I've got is, the new family of Quen models, the 3.5 family, the zero 0.8 to 9 billion parameters, which are feasible and very small devices. Have you any feel for how much improvement in performance you get using those rather than the models you did use?
All new models are mostly very good at tool calling because they are all new families of model have been fine-tuned to call the right tool at the right time.
No,
And in
I'm
that sense, they are
talking about the small family models,
Yeah.
specifically the Quen 3.5, very small family, but they're
I
not
would
using
say-
tools as far as I know.
Well, they do reasoning, and you can plug them into an harness, like So that wasn't the way that we were framing thing a year ago, but what we built was a very simple agent with a retrieval as a tool. So I would say if you use the new Quen, they will be way better at using retrieval. They will do retrieval way better than our previous model was just retrieving once and it was okay. The new Quen are really good at saying, okay, well, let me use this retrieval tool. Let me check the results. Oh, the results are not good enough. Let me retrieve again. And I think that's that plus a very good harness like Claude Code or Quen Code, for example, for Quen models, that will massively improve performance. I think, but going back to the question from before, it's very hard to then evaluate. Like, is it the model? Is it the task? Is it the harness that is playing the role?
Okay, that was the second part of the question. So can you talk a little bit about the problem domain selection?
It's very hard. The problem with this field is things are moving, well, either they are moving too fast or people think they are moving too fast, but then there's never time to actually evaluate things properly. I have a feeling that most of the time, a good harness, like by harness, I mean a software like Claude Code, okay? Ignoring the model that you plug in, but can be open code or Quen code or like a good harness is doing a lot there. And then if you take the same model and you put it in a different harness, performance will just go down. But that's a gut feeling because I don't even have time to check it properly. But I would say that instead of obsessing a lot about models, I think the combination of model and harness most of the time is the thing.
Okay, thanks.
Yeah.
Thank you. Brilliant. We will have to close now because Fede has to go to another meeting so he can develop another small language model probably, or another application of his model. So thank you so much, Fede. It's been brilliant. Thank you very much. Just for our group, just a reminder, we're an August meeting. We always take a summer break. So we'll be back in September on Tuesday, the 8th of September, where we're actually having my other group, the AI for Women's Health group. So all of our organisers, Bianca Score, Christine Callow and Annalisa, we are going to come and talk about our recent paper that's actually just been accepted this week, which is about accessible data for use in AI for women's health. So you can see that if you want to look in Nature Women's Health, it should be out next month. So we'll be coming to the next meeting to talk about that, our project we've been doing for the last year. So thanks very much, everybody. Thanks again to Fede, and have a good afternoon. Thank you.
Bye.
Bye.